So we want to find a polynomial p of degree 3 such that -2, -1, and 4 are zeros of p, and p1 equals 2. So the way we're going to do this is we're going to let a be the coefficient, and we're going to have the three factors here, or the three zeros. So we're going to subtract all the zeros. So it'll be x minus -2, x minus -1, and then x minus 4. Okay, so these are done. And the last thing we have to do is check that p1 equals 2. So right now, if I plug in x equals 1, I better get 2. So we have 1 plus 2 is 3, 1 plus 1 is 2, 1 minus 4 is -3, so 2 is equal to -18a, and so that makes a equal to -1/9. Okay, so we're just going to replace p of x with coefficient -1/9. And this is our final answer. Let's look at the next problem. Okay. So suppose p of x is a quadratic, q of x is a quadratic, and so is r of x. So we want to find p plus q of r of x as a sum of terms, each of which is a constant times the power of x. So this looks confusing, so let's kind of look at it closely. Basically what we're doing is we're taking p plus q, and then we're going to put in r of x. So it should be something like this. Okay, so first we're going to do p plus q. So p of x plus q of x. Okay, so p of x is x squared plus 5x minus 10. And q of x is -x squared minus 6x minus 2. So when we add these up, we get -x minus 12. So this part is done. But then we have to put r of x inside p plus q. So this is how it's going to work. So for every x, we're going to replace it with r of x, which r of x is 6x squared minus 10. Okay, and then this is minus 12. So simplifying it, we get -6x squared minus 2. And notice this is the final answer because each term, so we want to write it as a sum of terms. So here we have two terms, and we're separating it with a minus, each of which is a constant times the power of x. So the constant is the coefficient. So like -6x squared, that's the constant multiplied power of x. So this is the power of x. And -2 is really the same thing as -2 times x to the 0. So x is a power of 0. Oh, sorry. -2, you can think of it as -2 times x to the power of 0. Okay, so yeah, so this is the form that we need. And that's the final answer.